Hello everyone and welcome to another short video on solving a LeetCode problem with APL. Today we will be solving problem 1389, create target array in the given order. So the problem statement says that we are given two arrays of integers, a nums array and an index array, and our task is to create the target array under the following rules. So these are not really rules, these are like the steps that for the algorithm to create our target array. So we start with an empty target, and then from left to right we read each number and each corresponding index, and we take that index and in there we insert the current number, and we just do that until we've read all of the numbers and corresponding indices. And then obviously we need to return the target array, and they say that it's guaranteed that the insertion operations are valid. Fine. Now there's a little example over here. So we start off by, at index 0 we insert the 0, and so that's our target, and then at index 1 we insert the 1, and so we put the 1 there, and at index 2 we insert the 2, so there's the 2. But now we see again with the 2 over here, so at index 2 we insert the 3, and so the 3 goes on and appears at index 2, pushing the previous 2 to the right, and then at index 1 we insert the 4, and so at index 1 we put the 4 here, and this means that all the three other numbers are pushed to the right. So if we allow ourselves to write a loopy solution, a solution that looks kind of not so array oriented, then this is fairly easy to solve in APL. But I couldn't come up with a simple array-oriented solution, so I'll challenge you to come up with the best array-oriented solution you can, and then share it in the comment section, or maybe actually make a pull request to the GitHub repository that's hosting all of the different solutions that me and you folks come up with. So yeah, I challenge you to come up with a great array-oriented solution. I'll just show you a simpler solution, or not simpler in terms of like the ideas. Conceptually, it's very simple. So we have our indices and our numbers. And so what our solution does is, well, we start off with an empty target. So we define the target to be empty. And then what we need to do is we are going to iterate over the indices and the numbers. And we do that with the each operator right here. Now the each operator applies to the diff on the left, so now this runs for every index and number, and for that to happen we need to give the indices and the numbers as arguments to this diff. So we have the numbers on the left and the indices on the right. It could be the other way around, it doesn't really matter. And now the each makes sure that we traverse both of these at the same time. And now what we need to do is we need to update the target. Now the target is outside of the diff, so we are going to cheat a little bit and do the following. So we take t and we do the right tag gets. So this makes sure that the diff looks for the t in the global scope, so outside of the diff. Otherwise we are just going to create a local variable, and we don't want that. So we are kind of cheating here and working with this outer variable. And now what we do is t is going to get updated with what? Well, first, and I think I prefer the other way around, so let me have the numbers on the right and the indices on the left. Now the index gives me, again, man, sorry for the redundancy, the index in which I want to insert. So what I can do is I can do the alpha take of t. And now this is the number of elements that are going to be to the left of the index where I want to insert. Now I add the new number, and then to the right I have whatever is left after we drop alpha elements from t. And now if we run this and we ask for the value of t, I think this was the correct solution. Yes, 04132. 04132. Now all the work is being done by, well, each operator that is traversing through the indices and the numbers, but also this take and this drop. So let's take a look at one of the passes. So at some point we have that t is this. So at the very last iteration, t has this value, and alpha is the last index, and that's 1, because it's the last index, and then omega is the last number, and that's 4. Now we have t, so t is this, and we want to insert the 4 in here. We want omega to go there, right? Notice that index is 1, so how many numbers are there to the left of this w? It's only one number. And so, let's not run this. So if I do this a takes t, or alpha takes t, so a takes t, this is the only number that's to the left. And if I also do a drops t, I get the numbers that are going to get pushed to the right. And that's why this catenation here works. We just insert the number in the middle. And yeah, and that's about it. Now we want to wrap this in a full solution, so what we can do is, this was like a very small script, so we can write it inside our solution. 1, 2, 3, 4. So t starts off as the empty array, and then what we do is the indices that are going to be on the left, and then t, right take gets, the take, the number itself, and the drop. Now we don't need this parentheses, so we can omit it, and then the omega goes here, and finally, let me think. Yeah, finally we return t. Now we might need to do something to fix this or not. Let's see. Now the idea is that I can just call the solution. Can I print it? Oh, that's interesting. Okay, so now I'm returning the intermediate values, and that's because of this over here. So remember that the different returns on the last statement that isn't assigned, and this is not an assignment, so I'm returning at this point, and at this point what I'm actually returning is the result of this, let's call it iterating over alpha and omega. And as we iterate, what this different in turn is returning is what's being added to t. Yeah, so in order to fix this, what can we do? We can do one of two things. We can either sync this value, so assign it and not worry about it, and return the solution. And so this should work. Or we can do something else, and that's to take this value and, for example, return the last one, because the thing we cared about was the last intermediate value. So index solution nums. So this also works, for example. And now what's interesting is that in writing the solution like this, as the last of these intermediate values that we can see over here, it makes it clear, or to me it makes it more clear, that we could implement an alternative solution that made use, for example, of the power operator, and then the power operator could consume the indices and the numbers iteratively and just build this up without the need for this external variable here. But you know, for this, we don't want this video to get too long, and we are already at almost at the 9-minute mark, so I'll leave this as an exercise to you. So try to implement an alternative solution, perhaps using the power operator. And also don't forget that I will be very impressed with your array-oriented solutions, if you find any, so do give it a try, and I'll see you in the next video. Bye!